Welcome to the deep dive. Ever stop to think about how the software you use daily actually manages to work? Most of the time, anyway.
Yeah, when it does work.
Exactly. Well, today we're diving into functional testing, basically understanding how software really works or is supposed to work from, your perspective as a user.
That's right. We've been looking through some articles that really break this down. And our mission today really is to cut through the technical jargon.
Get to the core of it.
Yeah, get to the core of why it's just so vital for reliable software, the kind you don't want to throw across the room.
Please?
And hopefully by the end, you'll have a much clearer picture of what goes into making the digital tools you rely on dependable.
Okay, sounds good. Let's get right to it then. In plain English, what is functional testing?
Okay, fundamentally, it's about checking if software does what it's supposed to do. Does it meet the requirements? It's all about the what.
The what it does.
Exactly. Think of it like baking a cake from a recipe. The recipe says it should be a chocolate cake. Functional testing is checking, is it actually chocolate? Does it look and taste like it should?
Gotcha. So you're focused on the final cake, not necessarily the exact mixing technique or oven temperature.
Precisely. And a really key thing here is that we approach it like you would as an end user. It's often called black box testing.
Black box.
Yeah, meaning you don't need to peek inside at the code. You just interact with it. You put something in, click a button, type some text.
An input.
Right, an input. And then you check if you get the expected output or result. It's all about that interaction. Does the action lead to the right reaction?
Okay, interesting. So what parts of the software actually get tested this way? I mean, you can't test every single tiny detail, can you?
Well, you try to be thorough, but yeah, you focus on the key areas. Definitely the user interface or UI, that's everything you see and interact with. Buttons, menus, forms.
The visual stuff.
The visual stuff, yeah. But also APIs, application programming interfaces. These are the messengers that let different bits of software talk to each other. Super important, but usually invisible to you.
Okay.
Then there's the database, making sure data gets stored and retrieved correctly. Security aspects are often checked functionally, too, like can you access something you shouldn't?
Right.
And also client-server communication, how your browser talks to a website server. And importantly, this testing, it can be done by a real person clicking through.
Manually.
Manually, yes. Or it can be automated using special tools and scripts, which is obviously much faster for repetitive checks.
Right, okay. So sticking with this idea of what the software does, what are some of the main things testers are looking for? The key functionalities.
Okay, first and foremost, the mainline functions. These are the absolute core features. Why does the software even exist?
Like for a banking app, logging in, checking your balance, making a transfer.
Exactly. If you can't do those basic things, the app is pretty much useless, right? So those have to work flawlessly.
Absolutely.
What else?
Then there's basic usability. Is it easy to navigate? Can you find things without getting lost or frustrated?
Yeah. Like, is the search bar obvious? Are the buttons clear?
Precisely. It's about that smooth user experience.
Yeah.
Then, really important is accessibility.
Making sure everyone can use it.
Yes, including people with disabilities. Does it work with screen readers? Can you navigate using a keyboard? Things like that.
Crucial.
And something we can all relate to, error conditions. What happens when things go wrong?
Oh, yeah. You type the wrong password or try to upload a file that's too big.
Exactly.
Yeah.
Does the software just crash? Or does it give you a helpful message explaining what went wrong and maybe how to fix it? Good functional testing verifies those error pathways.
Yes. Those vague "an error occurred" messages are the worst. So frustrating. Okay, so how does this whole process actually, unfold? Is there a standard way they do it?
There's a pretty standard flow, yeah. It always starts with understanding the requirements. What is this thing supposed to do?
Makes sense. Start with the blueprint. Right. Then, based on that, the testers identify the specific test inputs. What data will they enter? What actions will they perform?
Okay.
Next, crucially, they determine the expected outcomes. If I do X, what should happen? They need to know the correct answer beforehand.
Right. Otherwise, you don't know if it passed or failed.
Exactly. Then comes the execution phase, actually running the tests, clicking the buttons, entering the data.
The actual doing part.
And finally, they compare the actual results with those expected outcomes they defined earlier.
And if they don't match?
Ding, 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 that's a bug or a defect, whatever you want to call it. Something needs fixing.
Got it. A systematic process for finding those gaps. Now, you hear lots of terms thrown around, like unit testing, integration testing. Are these just different flavors of functional testing?
They are definitely related, yeah, but they operate at different levels or scopes. Think about building a car again.
Okay, car analogy. I like it.
So, unit testing is like testing each individual component in isolation. Does the spark plug work? Does the door handle mechanism function correctly? Does a single brake pad meet spec? It's focused on the smallest testable parts of the code, usually done by the developers themselves.
Tiny pieces.
Tiny pieces. Then you have smoke testing. This is like, okay, we've put some big pieces together. Does the engine even start? Do the headlights turn on? It's a quick, high-level check to see if the main stuff works before doing more detailed testing. It tells you if the build is stable enough to even proceed.
Like a quick sanity check. Is it basically alive?
Pretty much.
Yeah.
Then there's user acceptance testing, or UAT. This is like letting the customer, the actual end user, test drive the car. Does it meet their needs? Does it work the way they expect it to in their real-world situation?
So the ultimate test from the user's view.
Exactly. Integration testing is about checking how different parts work together. We tested the engine unit. We tested the transmission unit. Now, does the engine correctly drive the transmission, and does the transmission turn the wheels smoothly? It's testing the interfaces and interactions between components.
Because individual parts might work fine alone, but not when connected.
That's a classic problem, yes. Then you've got regression testing. This is super important. Let's say you fixed a bug with the car's radio. Regression testing is making sure that fixing the radio didn't somehow break the air conditioning or the windshield wipers.
Ah, making sure you didn't introduce new problems while fixing old ones.
Precisely. You rerun previous tests to ensure existing functionality is still okay after a change.
Okay, wow, there are quite a few. Any more?
Just a couple more related ones. Localization testing is about adapting the software for a specific region or language, like changing the car's dashboard language, units, miles versus kilometers, maybe even features based on local regulations.
Tailoring it.
And globalization testing is kind of the step before that, designing the software from the ground up so it can be easily localized for different markets worldwide without major code changes.
Planning ahead for global reach.
Right. And finally, interoperability testing. This checks if your software plays nicely with other systems. Can your car's navigation system connect to your phone? Can it use data from external traffic services?
How well it integrates with the outside world.
You got it.
That car analogy really helps sort those out.
Okay.
Okay, so everything we've talked about so far is functional testing, what it does. You mentioned earlier about how well it does it. Is that different?
It is, yeah. That falls under the umbrella of non-functional testing. Functional testing confirms the features work according to the requirements, the what. Non-functional testing evaluates the characteristics of the software, the how well.
Okay, so functional.
Yeah.
The car drives from A to B. Non-functional. How fast does it go? How much fuel does it use? How safe is it?
Perfect analogy, exactly. Non-functional includes things like performance, is it fast enough? Reliability, does it crash often? Security, can it be easily hacked? Usability, how easy and efficient is it really to use?
Right. I guess you need the functional part to work first, right? You can't test how fast the car goes if it doesn't even start.
Generally, yes. Functional testing usually comes first to ensure the core logic is sound. The inputs are also different. Functional testing is driven by business requirements, what the user needs to do. Non-functional testing is often driven by performance metrics or quality attributes like the page must load in under 2 seconds, or the system must support 500 simultaneous users.
Gotcha. And what are some other non-functional types we might hear about?
Well, besides performance, load, and security, there's installation testing. Does it install correctly on different systems? Compatibility testing. Does it work on different browsers, operating systems, devices? You might also hear stress testing, pushing the system beyond its limits to see where it breaks.
Okay, that paints a clearer picture. Functional is the bedrock, does it do the job? Non-functional is about the quality and characteristics of how it does the job.
Nicely put.
Now, obviously, testing all this stuff, especially regression testing, doing it manually sounds like a nightmare. Automation must be huge here. Are there specific tools people use for functional testing?
Oh, absolutely. Automation is essential for efficiency and coverage. There's a whole ecosystem of tools out there. One that gets mentioned is testRigor. It promotes itself as being codeless using AI.
Codeless. Meaning you don't need to be a programmer.
Supposedly, yes.
Yeah.
It aims to let you write test steps in plain English, which could, speed things up and lower the technical bar for creating tests and potentially reduce maintenance.
Interesting. What else?
Then you have the big established players. Selenium is probably the most well-known open source tool, especially for automating web browsers.
Selenium, right. Heard of that one.
It's very powerful, very flexible. You can write scripts for it in lots of different programming languages. Java, Python, C Sharp, you name it, works across different browsers too. Huge community support.
The go-to for many web developers, sounds like.
Definitely. For testing APIs and web services, SoapUI is another popular open source option. It gives you a graphical interface, which can be easier for some, and it has features specifically for API testing, including security checks like vulnerability scanning and even trying SQL injection attacks, which is kind of a functional security test.
Okay, so specialized tools for different layers.
Yeah, and you'll also hear about others like QTP, which is now Micro Focus UFT, Unified Functional Testing. That's a commercial tool with a long history. And for developers, particularly in the Java world, JUnit is a fundamental framework often used for writing and running those unit tests we talked about earlier.
So a whole range, free, paid, code-based, codeless. For web, for APIs, it really sounds like ensuring software works correctly is quite the undertaking.
It really is. But ultimately, the goal of all this functional testing is pretty straightforward. Deliver software that actually meets the business needs and, just as importantly, works reliably for you, the person using it. Like one source said, the aim is a functionally perfect system. Maybe ambitious, but that's the target.
Yeah, functionally perfect sounds good to me as a user. Well, this has definitely given me, and hopefully you listening, a much better grasp of what's happening behind the curtain to make our apps and websites, actually function.
Hopefully.
So to sort of wrap it up, functional testing is fundamentally about verifying that software does what it's supposed to, from our perspective as users. It looks at everything from core features and basic navigation to handling errors properly. It uses a systematic process, involves various types of testing like unit, integration, and regression, and relies on a bunch of different tools, especially for automation.
That sums it up nicely. It's all aimed at creating that reliable, dependable experience we all expect. You now have a pretty solid idea of the work that goes into that dependability.
It's been super insightful, really. So a final thought to leave you with. Considering just how many different functions even a seemingly simple app performs, what's one piece of software you use every day where you really appreciate the functional testing? Or maybe one where you really notice the lack of it? Definitely something to mull over next time you're tapping away on your phone or clicking around online. Thanks for this deep dive.